We're going to start our discussion of real sequences by defining what a real sequence is. And a real sequence is just a function. It maps some subset of the integers that are bounded below to the real numbers. And since that's not a definition that we commonly use, let's go ahead and flesh that definition out a little bit, see what it means, and we're going to develop a little bit of notation along the way. Now you might recall that we said for a function to be well defined, we have to specify three things. So the first thing we need is the domain. So we're going to have a domain of our function f. And this is basically going to be some subset of the integers that are all greater than or equal to some other number. And this could be an integer or not, but just, for the sake of simplicity, we'll go ahead and let this be an integer. Okay? Now, typically, with real sequences, we're going to let the domain be the natural numbers, and that's what we're going to do for most of our analysis. So typically, the domain of our sequence will just be the set of natural numbers. So why don't we go ahead and draw out the elements of the domain. There'll be 1, 2, 3, ... We'll go out to some general natural number n, ... Okay? And you may also recall that the second thing we need to specify when we're defining a function is we need to specify the codomain. And that's the set that the function is going to map the elements of the domain into. And since we're mapping to the real numbers, because we want a real sequence, then our codomain is going to be the real numbers. So we can go ahead and write the codomain like this. This will be the set of all real numbers. And of course, last but not least, we need to specify the mapping. That is, it's the rule that tells exactly how each element in the domain is assigned to an element in the codomain. And of course, that's going to be given by f. So f is going to map 1 to some real number that we're just going to denote by x sub 1. So this is defined as the image of 1 under f. It's going to map 2 to some real number, x sub 2. 3 to some real number, x sub 3. ... all the way out to some general natural number n whose image we represent by x sub n. And then of course we just keep doing this for the rest of the natural numbers. Now, when we first learn about sequences, we're generally taught that they're basically infinite lists. And if you think about it now, knowing what we know, you can see that this is actually the function. Okay. So we usually let this parentheses x sub n represent the entire sequence. Okay, so in other words, x sub n would be written as this. Okay. And it's important to realize that this is not the range of the function. Okay, this actually is the function. If I want to find out what n maps to, I simply go to the nth place in this list and I find the real number x sub n. So this is actually another representation of the function. Now, even though this is very nice and very rigorous and a very clear definition of sequences, we're going to see that they're often written in different forms. And so next we're going to look at the three different forms in which sequences can be expressed.